Hi everyone, this video is on exercise 9J question 12. Fluid flows out of a cylindrical tank with constant cross-section. At time t, the volume of fluid remaining in the tank is V meters cubed. So we have the volume V. The rate at which the fluid flows in meters cubed per minute is proportional to the square root of V. So here is very important because this helps us to form the differential equation. Show that the depth h meters of fluid in the tank satisfies the differential equation dh by dt is equal to minus k square root of h, where k is a positive constant. All right, so for this part, first of all, we need to find a differential equation that is basically, giving us the rate of change of the fluid. So the crucial thing here is that so if you look at the part that I highlighted, it says that the rate at which the fluid flows in meters cubed per minute is proportional to the square root of V. So this is basically telling us the rate of change of the volume of the fluid. So dv dt, we can show that by dv dt is equal to, so dv by dt is basically proportional to the square root of V, right? Because here is saying that this rate, the rate of change, is proportional to the square root of V. So that's why we have v by dt is proportional to V. Now, at this point, we can then get rid of the proportionality symbol and just write this as a differential equation. So dv by dt is equal to, also, sorry, here is proportional to the square root of V. I forgot to write this. So dv by dt is equal to square root of V, but we have minus k here as well. So obviously, the use of k is very clear because it's proportionality and we always include a constant when we want to form the equation. But the reason it's negative is because the fluid flows out of a cylindrical tank. So that means the volume is constantly decreasing, the volume inside the tank. So that's why we have a negative constant here. Okay, now we are not done yet because this is just the rate of change of the volume of the fluid. But the question is asking us, show that the depth of fluid in the tank satisfies this differential equation. So we want to find the rate of change of the depth of the fluid in the tank. Okay, so you might have guessed by this point that this is a chain rule question, and you're right. So in order to form the chain rule, we first need to remember that the volume of a cylinder is equal to A times H, where A is the cross-section area, and H is the height of the cylinder. And in this case, if we want to find the HDT, we can form the equation here very quickly. So dH by dt is equal to, so as usual, we can easily form this by just looking at what parameters we have, so we can use them to form the equation and use the chain rule. So as you can see, we have dv dt, so dv by dt must be here because this dt in the denominator is also present, so that's good. Now for the second rate, it's very obvious that we need to have dh in the numerator, so in the denominator we need to have something that cancels out with dv, which means it must be dv. So now this is basically, if you want to find dh by dt, we need to have dv by dt, which we have found, and also we need to find dh by dv. So in order to find dh by dv, we actually, because we already have v is equal to a times h, so we can find dv by dh. Simply differentiating this gives us a, but remember this is dh by dv, so that's just the reciprocal of dv by dh, which is 1 over a. So this means dh by dt is equal to dv by dt, which is minus k root v, times the reciprocal of a, which is 1 over a, and therefore we get minus k root v over a. And remember that the cross-section area is a constant, so it's a constant value. Even here they have told us with constant cross-section. So it's just a constant number, like maybe it's 50, for example, 50 meters squared, for example. So, and also k is another constant. So a constant divided by another constant gives us another constant, right? So that's always a constant. So we can just simply show this time with lowercase k, as just, to follow what the question has done. So can therefore show that dh by dt is equal to minus k. But before that, there is one more step actually, because I need to do something else, otherwise I need to repeat something. So yeah, let's just do this first. So there's another thing that I need to mention, and that is, so we have minus k and then times. Now instead of writing square root of v, remember that we mentioned v is equal to a times h. So we can write like this. The reason is we want to have h, a square root of h, to to get the same form as here. Okay, now we can split the set. So k times minus k times the square root of a times square root of h divided by a. Now this is the point that, yeah, we can do that, because earlier when I was talking here, we could have done that, but then we needed to do one more step of introducing a new constant, which would be messy. So that's why I just decided to do every simplification first and then introduce the final constant to get this form. Okay, now again the same logic applies here. So a is a constant, square root of a is a constant, and minus k is a constant. So three constants. So this constant times this constant divided by this constant gives us another constant, which we can show with the lowercase k. So we now have dh by dt is equal to minus k square root of h, where k is a constant. And this is exactly what we wanted to show as here. dh by dt is equal to minus k square root of h. Okay, that's it for this video, and thank you for watching.